Hello students, welcome back into our usual meetings. This is our 11th topic where you'll be introduced to Trigonometry I. Right, so as usual, stay tuned. If somewhere you have a paper, I would urge you to do the scribbling here and there. Right, without wasting much of our time, let us first of all define the terminology, trigonometry, and after we need to see the objectives of the topic. Right, here with me, it's just like a brief definition of trigonometry. But if you go further into the study, it may more especially if you go into the internet, you'll be able to realize that the definition of trigonometry is very wide. But here we just brief up because of our interest sake. Now, trigonometry is simply defined by what is here on the chart. It's just a branch of mathematics. You know, there are several branches of mathematics. You talk of algebra, talk of arithmetic, but here we talk of the trigonometry, which is a branch of mathematics that studies the relationship between the angles and the sides of the triangle. So everything that we have here, it's about triangles. Right, so it means you have to shift your mind from whatever we've been doing in the past. We talked about all those algebraic expressions and the like. Now put that one aside. Now we see about the triangle. Right. This trick uses trigonometric functions such as sines, cosine, and tangents in order to define the ratios of sides within a triangle for a given angle. So what it means is just like whatever we have here is a study that everything that we do is about the triangle, where we'll be working out problems related to the triangle, in which we'll be using the sine, cosine, and tangent functions. Right. Now, having defined what trigonometry is, where we are looking at the relationship between angles and sides, now let us look at the objectives that will take us through. Objective, right? We are to do the following. As students, you must be able to calculate, that's now by the end of the topic, should be in the position to calculate angles and sides of the triangle, which is right angle, in this case, by this trigonometry I, using trigonometric ratios. And that's now we are going to derive fractional trigonometric ratios of what we call them as special angles, of 30 degrees, 45 degrees, 60, 90, and 0 degrees. These are special angles who have their special trigonometric ratios of them. Then lastly, we will be able to work out practical problems using the trigonometric ratios. On this part here, we'll be focusing on issues like elevations, angle of elevations, angle of depressions, problems related to that. And then we are also going to look at the problems which are related to bearing. These are just like a real life type of problems. They talk of the reality on the ground. So it's more like once we have known something about the trigonometry, the ways how we can do them, then now we have to see why do we learn this. So there'll be something like a certain reality where you need to do that one. So where we are going to solve that practical problems using the trig ratios as such. Right, now the first thing that we do here is first of all to get to know what it is about the trig one. Right, the moment I've indicated the trig one, it means we have got categories of trigonometry. Really, we have trig one, and somewhere it means we've got another type of a trig, that is trig two. Right, so we have already defined trigonometry, that is the branch of math that deals with the what? Triangles. So in this case, the moment we talk of the trig one and trig two, we talk of the triangle, should be able to sense out that there is a category of kind of triangles that where we are going to look at the relationship that exists between the sides and the angles. In Trig 1, specifically, we'll be dealing with triangles which are light angled. Right. In Trig 2, it will be a discussion that will be looking at the triangles which are not light angled. These ones are known as scaling type of triangles. Triangles which in their nature don't have a light angle. So that's it. So this one is left side face. We'll look at this one in the class level, that is what, Form 4. But here in Form 3, we'll concentrate on the Trig 1. So here is where we are going to focus much on the what? Talk of the trigonometric functions. We'll be looking at the ratios, which are defined as sine ratio, cosine ratio, and the tangent ratios. So really, I wanted to give you at least a foresight of what it is about the trig definition. Then we talk of the branches of the trigonometry that we have our level. We talk of Trig 1, Trig 2. Trig 1 deals with right angle triangles, while Trig 2 talks to this kind type of triangles. And here we're going to focus much on the rules that we're going to do that will be able to help us into that weaker problems related to such type of triangles. Right. Now, let's get into business about Trig 1. Right, so everything about Trig 1 needs you to know the ratios. Right, the ratios that we're going to discuss here are 1, talk of the tangent ratio, we'll simply brief it like tan. Secondly, we'll discuss the sine ratio, which is simply briefed as sine. And the third ratio is defined as cosine ratio, which is briefed as just like cos. So you talk of tan, sine, and cos. So these are the ratios that will be there, going to be rated in the sides and angles of the triangle, and the ones that we need to know in order to work out problems which are related to the right angle triangles. Right, now, what is a tan ratio? What is a sine ratio? How do we come up with the cosine ratio in terms of the sides and angles of a triangle? Right, so I may not be too much in detail about this, but I'll be there at least giving a foresight of what it is about the tan ratio related to right angle triangle, and also about the sine ratio, and again what is the cosine ratio related to the sides and the angle of the triangle. So the first thing that we need to know before we talk of the ratio that is tan, sine, and cosine, it is very important that we get to know about the name of the sides of the right angle triangle itself. So once we have known that, it's now going to be able to drive out the ratios of which are defined as tan, sine, and cosine. Right, so let's discuss the triangle itself, which is right angled, the one we are focusing upon in the trigonometry 1. So right angle triangle, we all know it's a triangle within which we have one out of the three angles being right angled. Like this one, if I draw one here, just a sketch, a right angle triangle must look something like this. Can be drawn in any form, but what is more important is you should be able to see that in the triangle itself, one of the three angles should be what? Right angled like that. So these are the two angles, remaining angles in triangle ABC should be the angles which are just acute, angles which are less than 90 degrees. You can't have this one 90, that one 90, while this one is already 90. We know for sure that the angle sum of the triangle is 180 degrees. So it should come up with that. So which means this should be less than 90, that one should also be less than 90. Right, so this is an example of a right angle triangle. Right, so how do we define the ratios? First, let's get to know about the triangle itself. What's more important here are the sides. We have got three sides. Any triangle that you have, you come across about right angles, should be able to have the three sides like this one. Out of the three sides, there's always one side which is the longest. No matter what, that side will always be the longest. And that side is the side that is opposite the right angle itself. Like in this case, in triangle ABC, the longest side will always be the side AC, that is opposite the right angle. This is right angle. Opposite means that the side is facing a particular angle in this case. And this side is defined as the hypotenuse. Right. So that is the hypotenuse side. You can just brief it by a capital letter as H. So the longest side on the right angle triangle is hypotenuse side. Right. The remaining two sides, if we go by JCE, which are now the sides like BC and AC, in JCE we just find as legs, but this time around we've got a different definition of them. Right. These two sides can be defined by any of these definition: opposite, side, or top of the adjacent. They can be defined as adjacent side or opposite side. Right. So what determines being a side defined as opposite and what determines it to be as adjacent? Right. Because this is not fixed that this one is opposite or say adjacent. No, it depends. But now for the hypotenuse, it's must. It's just the one, and it's like that one does not change. The name is hypotenuse because it's the longest and faces the right angle. Right. So what determines the name of the side adjacent or opposite is a particular angle, because remember what I indicated earlier in the definition to say that trig is there to discuss the relationship that exists between the what? Sides and angles. So it is a particular angle that is of your interest. In this case, talking of the remaining two angles which are acute that you are interested upon, that will determine the name of the side. Let's try to understand here, because the depth or the main focus of this topic relies on the definition of these sides. The ratio that we need to know has to be always be known truthfully by the name of the side. So try to understand here when we're discussing the side, and this will determine the type of what a ratio that we're going to discuss later. Right. Suppose I'm having this angle here. That's the angle that we're given. Let me represent it by a symbol theta. This is not cube, but talk of as a theta. A symbol that represents any particular angle can be any angle, whatever it is, 40, 60, and the like, but should be less than 180 degrees. And let me call this one as maybe theta, another symbol for angle. So this is angle theta, this angle beta. Now, if we are interested on this angle, or say if I should talk of this angle here, if we can consider this angle here, you'll be able to see that this angle is opposite to this side. And this angle beta is opposite to that side, which is BC. It means this side here, AB, the remaining sides out of the two sides, this AB, this side will be defined as opposite side to angle theta. So in this case, if we're interested in that angle, it means that side is opposite side to angle theta. But now, this side BC can also be an opposite side. If we are there to look, if we are to consider this angle here, this angle is opposite to this side, then this side we define as opposite side. This angle is opposite to this side, then we also define this one as the opposite side. So this way it goes. What angle are you considering at particular instance? Right. Now, the remaining side, you'll be able that side is just adjacent to a particular given angle, and that side is just defined as adjacent side. So like in this case, look at this. Let me consider angle theta in this case. This angle is opposite to this, and this one then we define this as the opposite side, and you can represent it by capital O. It means this remaining side, as you can see it's just the side in which this angle theta is being formed. So you say this side is opposite to that angle, is adjacent to that angle, then you define this side as the adjacent side. So this remaining side, if we are considering angle theta, this one must be termed as adjacent side, and represent it as the A, like that. But now, if I'm now to consider this angle up there, the beta, you be able to see that what I've discussed about this side here is true again about this side. Instead of having theta, what I've talked about theta is the same as beta. So it means this side here now is adjacent. This side now is adjacent side to angle beta. then it means this side will be what? Opposite side. So it means from what I've just explained here, you'll be able to learn that adjacent side and opposite side, it depends with the type of the angle you are considering in the triangle itself. But the hypotenuse side remains fixed. Right, so to take it brief, let me just now draw a triangle. To summarize what we have discussed here, you should be in the position to take that, say, if we are given a particular triangle which is right angled like this, I'm going to draw this one again, like this one, right, every time. Try to know that if this is my angle given, it's the theta, and this one is a right angled triangle, sorry, this one is a right angle, you call this one as KBX, that's the description of that triangle. Please get to know, consideration is the theta, then this one is the adjacent side. This one will be described as what? Opposite side, but this one will be what? Hypotenuse side. Right, so that's the way it is about the trigonometry in the first instance when we talk of the issues about the right angle triangle. Try to understand this definition here. Now, let's go to the ratios themselves. Right, ratio just talk of the relationship that exists between two quantities. So like in here, we are also going to look at the relationship that exists between the two quantities. Right, so here we'll be talking about the length of the sides of the triangle. How long is KB? How long is BX? How long is it? KX. Right, now in relation to a particular given angle inside, which is an acute angle. Right, then from there, we'll be able to define the ratio of those two, any two sides there, as sine, cosine, and tangent. Right, so now, let's see, first of all, take the ratio of any two sides here. If we have the ratio of the opposite side to the adjacent side in relation to angle theta, a ratio of the opposite side to adjacent side, which can also be written as opposite over adjacent. Still more, that is opposite to adjacent side in relation to angle theta. That ratio is defined as a sine of, that's the tangent of angle what? Angle theta. And in this case, this one is written as tan theta is equal to opposite over adjacent. So it means if you take the ratio of opposite to adjacent, that ratio will be able to give you the value of angle theta. That's what it means in this case. So whatever length you have for the adjacent opposite side and the adjacent side, that one will be able to give you the value of angle theta in this case. That is to understand ratio. Right, on the other side, if we take the ratio of, let's see, the adjacent side to angle theta. So when I'm talking about the theta, try also to consider that sometimes you have this angle, it means your adjacent side now will be this one. Right, so let me just use this one here because of time. Whatever I do about this, you can also do for that. A ratio of the adjacent side to the hypotenuse side, that is A, that's talk of the BX to K, that is talk of what? KX, adjacent to hypotenuse side in that case, which can also be written as the adjacent to hypotenuse side, considering it as talk of the BX to what? KX. This is adjacent side, this is opposite side. That ratio is defined as the cosine ratio. So it means the cos of angle X can be worked up when we divide the adjacent by the what? Hypotenuse side. So this is the second ratio where you take the relation between the adjacent to the hypotenuse side. Right. So here, this one is written as the cos of theta is equal to, let's say, adjacent to what? Hypotenuse side. Please try to understand and take note of this word, ratios. This is the main focus. Once you do this one, it means the rest of the story, you see, it's very simple to do it. Master this one accurately. Lastly, the last ratio that we need to know here is the ratio about the sign. This ratio of the sign considers the relation between side, which is the opposite, in this case, talk of KB, to what? To KX. That's the opposite to what? Hypotenuse. Written as opposite to hypotenuse, more like in the fraction. This gives us what? That's a sine of angle theta. Right, so that's the way it goes in here. So by this, if you can replay the video backwards, you'll be in the position at least to master the ratios as such. How do you find the tan ratio? How do you find the cosine ratio? How do we come up with the what? Sine ratio. Right, so in case sometimes you may need to master this one and you don't have to forget, there's at least just a name that is coming from this ratio that you can be able to go by it. Once you master that, you'll be in position what those letters within it mean. Right, so let me take you into that. Right, so look at this about what we have discussed in here in the triangle that is right angle. We have talked of the ratios, which are 1. We talk of the sine of an angle, which now in brief, like said, angle theta. This one is coming up when we divide the opposite over hypotenuse, first ratio. The second one, we are talking of the cosine of an angle, described as cos of theta, which is coming from the division or say the ratio of the talk of the adjacent to hypotenuse. So I'll write it as A over hypotenuse. Finally, we have also talked of the tan ratio, which is the ratio of the what? Talk of the opposite to adjacent, written as O over adjacent, which is A. You can now produce a name from this one. The moment you consider the first ratio is the sine, the second one is cosine, the second one is tangent. If you can't forget the ratios here, so opposite over hypotenuse, adjacent over hypotenuse, and also talk of the opposite over adjacent, you may be able to consider the letters only to say from this, like say the first ratio, if we take the abbreviations, this is opposite, this is hypotenuse. You'll be in the position, if you consider the sine, we can just consider the S only here and write it as S. S is developed from what? Opposite, we just consider O, hypotenuse, consider H. It means S can be found when you divide opposite by hypotenuse. So in that order, tells your story. First letter is the description of the ratio. Second letter is the first side that gives you that ratio. The last one is the side that always will be able to be considered in the ratio itself. So it's just like this one over this. So it's like you write so. It means sine is found by opposite over hypotenuse. Secondly, you connect the so with the as abbreviation in the second ratio of the cosine, where you have got cos, you write S is found by what? Dividing A by H. So you say talk over not S, but now here talk of C. You divide A by H. So 3 letters again, as it was in the first instance. This talk of the car, this is car. You talk of cos is found by. So here, let me just highlight this one here. This is the name of the ratio. This is the name of the ratio. Right. Divided by, so talk of the adjacent divided by hypotenuse. Finally, we have got the tan, which is written as T in the abbreviation. I also highlighted by a mark down here. Right. Found when you divide opposite by adjacent. So the way here comes in as SOHCAHTOA. So you should not be interested in the name, but just be able to understand what do those abbreviations or so those letters mean. So it means sine is found by opposite divided by hypotenuse. Then the next pair, the next 3 letters tells you a story about the other ratio. Cosine is found by dividing hypotenuse by what? Adjacent. The last third of letters tells you the last ratio, which is tan. Tan is found by opposite by divided by adjacent. So I all hope that you know the opposite side, adjacent side from the first discussion, where I really had to emphasize what is the adjacent side, which is the opposite side. So this is what we need to know in the first instance about the trigonometry 1. Right, so at the moment, let us first of all stop here. In the next lesson, we'll now be going to discuss on how we can use these three trigonometric ratios to work out the problems related to the right angle triangle. Thank you very much for being together, and I ask you always to revise this by the link down here now and again so that you have to master the concepts. Thank you.